All right, here we go. So, if you haven't completed your online formative yet, that was supposed to be done last night or by yesterday. We gave you time in class. It'll take you like 5 minutes, maybe 10, okay, at most 15. Get it done, okay? Because I don't want you to get farther and farther behind. I think everybody in here took it, so we're good to go with that one. Okay? So for two warm-up problems here. So first one is, okay, good, just those two. Okay. So given that the sine of theta is negative 3/5, find me the cosine of theta and find me what the sine of theta plus pi is. And then the second one, I want you to find theta, given the fact that the sine of theta is negative 1/2, and that theta lies within that range. Okay? So find me those two. Good warm-up problems. All right, so cosine squared. I guess we're going up theta this time. Cosine squared of theta plus sine squared of theta has to be 1. 2 x squared plus negative 3/5 squared is 1. So that's going to be x squared plus 9/25 is going to be 1. So x squared is going to be 16/25. So I get x here is 4/5. And since we don't know, we weren't told what quadrant we were in, we know that we're either in quadrant 3 or 4. We need to give that one. Okay? Sine of theta plus pi would be equal to, the opposite of the sine of theta. So I would negate negative 3/5, and then that would give me positive 3/5. Yes? Love it. Okay. So sine is negative. Okay, sine is negative 1/2. And we said that that was our y value. So I'm looking on the unit circle for a sine value of negative 1/2. That would put me, just that, would put me at 7 pi over 6 or 11 pi over 6. This second classification tells me that I am in quadrant 3. And so between those two, my possibilities, theta would be 7 pi over 6, because that's the one that's in quadrant 3. 11 pi over 6 is in quadrant 4. So that fits both classifications. Or conditions, I should say. Good? Okay, love it. Let's talk a little SOHCAHTOA today. Okay? So you learned way back in the geometry all about right triangle trig, SOHCAHTOA. Okay? Sine, the sine of theta, the sine of any angle in a right triangle, is equal to the opposite side divided by the hypotenuse. Okay? That's the so part. Ka, the cosine of that angle, of that same angle, is the adjacent angle divided by the hypotenuse. And tangent is opposite over adjacent. Okay? So we're going to utilize that today as we go through. So we need to solve for the variable. Well, we first have to identify what we all have. Okay? So here is my angle. Okay? That's the angle that I have. The opposite side would be across the triangle from it. The adjacent side would be touching the angle right next to it. And the hypotenuse would be across the triangle from the right angle, the longest side. So in this particular case, I got the adjacent side and the hypotenuse. AH, that is ka. Okay? So I'm going to say that the cosine of theta is the, oops, I've almost put opposite there, adjacent over the hypotenuse. So, back to this then. So the cosine of our angle would be 39 degrees. Side note, you're going to need a calculator for this part. Okay? Is going to equal the adjacent side would be 23 over x. So if I'm going to solve for x, I'm going to flip-flop those. Okay? So x is going to equal 23 divided by the cosine of 39 degrees. First off, make sure that your calculator is in degrees. And second off, make sure that you type it in correctly. Okay? So I get here 23 divided by the cosine of 39 degrees. I get x is 29.5955. Usually, we round to tenths when we're dealing with sides. We will tell you in directions what we want it rounded to. Okay? With that being said, please at this time find me x in that particular triangle. Okay? You think? So we've got opposite here, and we've got hypotenuse. So that is going to be the sine. Color code everything. Sine of theta is going to be opposite over hypotenuse. So that is going to be the sine of 66 degrees is going to equal x divided by 50. We multiply both sides of that by 50. And I get 50 sine 66 degrees. I get 45.6773. So we would call that 45.7. Yes? Okay. We can also utilize a right triangle, and we can find all 6 trig values within it. Okay? So before we start that, however, we seem to be missing the hypotenuse. Okay? So in a right triangle, what's the one tool in my toolbox that I have to find a missing side? Pythagorean theorem. Yep. So a squared plus b squared equals c squared. So in this case, it would be 5 squared plus 12 squared equals c squared. That's 25, 144, that's 169, so that's 13. And I only have to go with the principal one here because the side length of a triangle can't be negative. Okay? So h here, oops, I should have put h for those. Let me go back and change that. Okay. Yep. So, with that being said then, now we can find what the cosine of theta is. So cosine of theta, that would be adjacent over hypotenuse. That would be 12/13. Which means then that the secant of theta would be 13/12. Because those are reciprocals. The sine of theta is going to be the opposite side over the hypotenuse, which means then that the cosecant would be 13/5. The tangent of theta would be opposite over adjacent, which means the cotangent of theta would be 12/5. And those are the 6 trig values off of theta. Yes? Love it. Okay? What I would like you to do now is I would like you to do the same thing based off of that triangle. So we've got x squared plus 9 squared is 13 squared. So I got x squared plus 81 equals 169. So I got x squared is 88. Yep. So then I get x here as the square root of 88, which is going to be 2 square roots of 22. Right? Okay. So, cosine of theta is going to be adjacent. So that would be 2 square roots of 22 all over the hypotenuse, which is 13. So then the secant of theta is going to be, and now I'm going to go down here and I'm going to say, well, because it really would be 13 over 2 square roots of 22. That would be square root of 22 over the square root of 22. So I'm going to say that that is 13 roots of 22 all over 44. Yes? Then the sine of theta is going to be 9 over 13. Cosecant of theta, 13 over 9. Tangent of theta, opposite over adjacent, so that would be 9 over 2 square roots of 22, so then that's just going to be 9 square roots of 22 all over 44. And the cotangent of theta would be 2 square roots of 22 all over 9. Questions, comments, concerns, clarifications, haikus, limericks? Got it, so? Okay. Good, good, good. All right. So, if theta is an acute angle, find the other 5 trig functions of theta. So we know here, so in this one, it helps to draw ourselves a triangle. Okay? And then let's put theta down here. Really, it doesn't matter. Okay? The right angle is here. It really doesn't matter which way you draw your triangle. Okay? Sine is opposite over hypotenuse. So this side is 2, and this side is 3. So then let's call this missing side x. So then x squared plus 2 squared would be 3 squared. So I get the square root of 5, right? Okay. So the 5 other trig functions then would be cosecant would be 3/2. Cosine would be square root of 5 over 3. Secant would be 3 over the square root of 5, which would just be 3 square roots of 5 over 5. Tangent would be opposite, so 2 over the square root of 5, which would be 2 square roots of 5 over 5. And cotangent would be square root of 5 over 2. Questions on that? Tripped and fell right in through the table. tomorrow, there are 2 videos to watch, okay, on His Learning. They're on the content page for tomorrow. Okay? And then you guys can start, I believe the first worksheet that you picked up in the back was the 4.2 worksheet, okay, today. And then Monday, we just want you to finish off that